Hi everyone, welcome to this video. In this video I'm going to show you how to do a power analysis for a correlation coefficient using a software called G-Power. So I'm going to put the link to install G-Power if that's not installed on your machines. And let's see how to use it. As an example, we'll suppose that we're interested in studying the correlation between stress levels and sleep quality in adults, and based on a meta-analysis of prior research, fictional one, we estimate the correlation coefficient to be around 0.3. And so we aim to detect this correlation as significant with a statistical power of 0.8, which is a commonly used threshold, and the alpha threshold for significance will be 0.05, which is very common, of course, in the social sciences. So the first question is what is the required sample size, and the second question is we're going to solve for a statistical power knowing sample size. So let's do the first one. What is the required sample size in this situation? So what I'm going to do once I've launched G-Power here is I'm going to select t-tests here, and I'm going to use this one, the one that's already selected here on my machine, which is linear bivariate regression, one group, size of slope. And I'm going to select a priori compute required sample size as the default, given alpha, power, and effect size, which is exactly what we have here. Let's say I aim to do a two-tailed test rather than a one-tailed test. And here, what I can do directly is, since I already have a standard deviation of 1 for both of my variables, actually, if I just provide the slope, it will correspond to the correlation coefficient. So I can directly provide here the correlation coefficient. So I said it was 0.3. Right? The alpha threshold is still 0.05. I'm not changing anything. However, statistical power, I'm aiming only for 0.8. And this one I'm not changing. That means that we're comparing with a null hypothesis where the correlation is null, which is what we do most of the time, of course. And that's it. So I'm going to click on calculate. Boom. And what it tells me here is that I would require a sample size of 82. And I would achieve with a sample size of 82 a statistical power that's actually, of course, slightly higher than my 0.8, but nearly the same. Okay, so that answers the first question, what's the required sample size. Now, if we want to solve for statistical power knowing sample size, so let's say we know that we would study that we would have about 100 participants, and we want to know if that's enough statistical power. What I would do is select instead here compute achieved power given alpha, sample size, and effect size. And as you can see, you can solve for different things. So if you want to solve for an alpha threshold, or if you want to solve for a required effect size, that's also possible. So here what I'm going to do is a post-hoc power analysis. So clicking here, compute achieved power. So I'm going to keep the same slope. It hasn't been changed, 0.3. Alpha threshold still of 0.05, but my sample size here is 100. And I'm going to see what statistical power I would get from that, and I'm not changing anything else here. So I'm clicking on calculate, and I see that I would have an observed power of 0.88, about that. So yeah, so that's pretty straightforward. Of course, the main difficulty in power analysis is actually getting a number here, knowing how to estimate your effects. You know, for some situations, we can make educated guesses, have a meta-analysis, perhaps, but that's a previous study, at least. But that's not always the case, especially if we're running complex models, maybe with mediations, moderations, and things like that. You know, you may be the first. It may be the first time that someone actually runs the model you're running. So So that can be challenging, but in this relatively straightforward example, it's pretty easy actually. Thanks for watching.